All right, so this final thing we will take a look at here, it does involve angles. It's not going to be in triangles anymore, but it does involve angles, and it involves parallel lines with a line running through it, and some of the relationships happening there. It's going to be easier just to jump right in. So first off, these lines right here are parallel. That just means that they're never going to touch. All right, they're running side by side. They maintain the same distance. They're never going to touch. They're just going to go on forever like this. Now, because of that, they kind of run at the same angle, basically. And so there are some special relationships. Now, this line right here is called a transversal. Maybe just think of the fact that it transverses the two parallel lines. And all it is it's transversal is just a line running through two parallel lines. But this helps us to talk about and understand some of the angle relationships happening here. Okay. Now, one thing to keep in mind is, first off, if I were to just basically for right now erase and make my pen bigger. If I were just to erase this, by the way, this holds a lot of the same relationships that we know from last week. So actually, I'm going to erase a whole bunch of this to where all we have left is this angle right here, is 1/28. And so this angle right here has to add up to 180 with 1/28. So take 180 and subtract 1/28. That would be 180 minus 1/28, 52. So this angle has to be, 52 degrees. These are still what's called a linear pair from last week. Two angles, they add up to 180. They're right beside each other. They create this straight line right here. Now, let me do some erasing. Because we know a little bit more then. Because, check this out. This is a straight line. This angle right here is 52, so this angle has to be 1/28. And again, this angle and this angle would have to add up to 180, so this has to be 52. So that's kind of cool, actually. What you find is, first of all, the angles across from each other, the big angles, the obtuse angles, are both going to be the same, 1/28. And then these two would also have to be the same. They're across from each other. And what we know is that there's a lot of linear pairs in there. For example, these two angles in blue have to add up to 180, as do all of the angles around it. So what you find is, first off, all of the big angles are the same. All of the small angles are going to be the same. And this actually carries to, check this out, we still have a line down here. We haven't even answered the question yet. But what's cool is these all slide down the transversal. So these things all just kind of slide down. So all of the small angles here are 52, 52, 52, 52, and all of the big angles are 1/28. And so our angle in question is 120 degrees. So make sure there. You don't need the degree symbol. That's fine with me. But all of the angles around there add up to 180, and they're all the same, and they slide straight. And they slide straight down to where you're only in these situations. You're only going to have two types of angles. The small ones are all the same. In this case, they're all 52. All the big ones are 1/28. So let's do that again. All right. So we know 1/22. And we know the angle that we're missing is also a big one. So now you could sit here, you could do, seriously, we know the big one on this one is 1/22. We know that 180 minus 1/22 is going to be 58, so these are 58. and then just slide it down. Slide it down. The small one is 58. The big ones are 122. Or from the very beginning, check this out. We know these lines are parallel, so they hold these special rules to where all of the big ones are 122 and all of the small ones would be 58. This is a big one. You can just find one of the big ones, one of the small ones, and you know this is an obtuse angle. Obtuse being greater than 90 degrees, so you know this has to be 122. You don't have to find it every time. Unless you're having trouble, then I want you to do that. All right, same thing here. So we're given 120. It is a bigger angle. It's obtuse. The angle we're looking for is a small angle. So we need to find the small angle. So 180 minus 120 give us this one is 60. Big ones are 120. Small ones are 60. You can label them all around the circle if you'd like. There you go. So that means that this has to be 60 degrees. All right, last one. Now, this is where things could get a little tricky, and this is where you might want to list them all out. It's hard to tell which ones are which here. Now, 87 is technically the smaller one, because if we find 180 minus 87, this is 93. This is going to be bigger. Oh, well, then I found the answer. All right. It can be a little hard if your angles look very similar, but they're not the same. 87, and then we know that 87 plus this angle add up to 180. It's 93. There's your answer. All right, and that's pretty much it.